So this video is going to focus on factoring by sum and difference of cubes. This one's a little bit, doesn't happen as often and kind of takes people by surprise. It's not a terribly tough equation to kind of work with when you're in this section. It's just hard at the end of the semester when this gets thrown at you out in the middle of nowhere, or in a later class like in calculus where you're trying to solve a problem and you don't recognize it right away. So anyway, you get these two kind of nasty looking equations, but in the end you just have to figure out what A is and what B is, and like the quadratic formula, you just plug them in the right spots, and unlike the quadratic formula, it's done at that point for factoring. So we get something such as like x cubed minus 27. The first thing we have to know is what all of our cubes are. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 125 is 5 cubed, and that's generally as high as you really have to go. After that, if you see kind of a bigger number, you're going to want to use your calculator and say, okay, what's the cube root of that, to kind of work backwards. So these are the main ones we're going to work with. Not that you can't see other ones, but that's 2, 3, 4, and 5. After that, I don't know what 6 cubed is off the top of my head. I could give a guess, but I don't want to be wrong on the internet. So anyway, the main idea here is we just have to identify what A is. So A is just X. So if you look at your little equation, you have it right in the right spot there. And then B is something cubed here. Well, if I have 3 cubed in that spot, B is 3, not 27. So it's something cubed. So whatever that cubed is, it's 3 in this case. So if there was a 64 here, then there would be a 4. Now, notice there's a sum of cubes and there's a difference of cubes. There is not a sum of squares, there's only a difference of squares. Now these two equations, at first glance, they look like they're a lot different, but they're not really any different. This is a plus, then this is a plus. This is a minus, and this is a minus. These next two signs switch. This is a plus, this is a minus. This is a minus, this is a plus. So if you get the first one, the second one just is a flip. And AB plus B squared, AB plus B squared. It's exactly the same thing. The other thing that people won't get wrong here, which is wrong or right kind of depending on how you think about it, is I wrote down B was 3, not negative 3, but regular old 3. That allows me to just use the second equation the way you see it. So what this equals to is A minus B, so A is X, minus 3. And the other part would be A squared, so X squared. It's a plus AB, 3x, plus B squared, which would be 9. That's it. You're not going to be able to factor this. Period. Problem is done. Circle it, move on to the next one. Alright, well, let's try another one. This one doesn't look right. 2x to the fourth plus 2x. It's not to the third, but there's a GCF. Take out the 2x. Leave us x to the third plus 1. Don't forget your 1. Now A is x and B is 1. 1 cubed is 1. So our answer is, don't forget the 2x out front. It's addition, so the plus, so x plus 1. And then leaves us with, well, A squared, so x squared, minus now AB plus B squared plus 1 squared, which is 1. And that's our final answer. Let's try to solve this. X cubed plus 125. Okay, well, from here we're going to realize we're going to solve by factoring. So x is our A and B is 5. Okay, so from here we're going to go with we're going to factor it to begin with. So A plus B, so x plus 5. A squared, so x squared. It's plus, it gives a minus 5x. And then plus B squared, so plus 25. Now, we want to set this equal to 0. As far as our class goes, we haven't really done the quadratic formula yet, so our first factor, x plus 5 equals 0, x equals negative 5. Now, this part right here we'll find out later, can be solved with the quadratic formula. It will not be factorable, so -5 is all we can do as far as this section is concerned, as far as solving by factoring. But anything that's raised to the third power should have 3 answers, 3 roots. And we've only found one of them so far. But rest assured, if you do the quadratic formula, you will find the other couple. Alright, let's just do one more practice problem. Let's use one of the ones we haven't used so far. So let's go with alright, 64x cubed minus, now here's the part that's a little bit tricky. If I want to use like 16 goes into 64 and all that fun stuff. Try not to have too much with the GCFs, because we have a problem over there. A lot of times things get repeated really fast. So we'll just go with 27 again. And we'll go with y cubed this time. So now A is our 4x and B is our 3y. Because 4 cubed is 64, 3 cubed is 27. So we'll start with A minus B, because we have subtraction. So 4x minus 3y, and then we do A squared. Now it's A squared is 4x squared. It's really 16x squared, not 4x squared. 4 squared, x squared. If it's a minus, it's a plus. Multiply them together, 12xy. And then plus b squared, 9y squared. When you're squaring a and we're squaring b, make sure you're squaring all of b, not just the y. Again, this is not going to be factorable at the end, so this is our answer.